Hello, welcome to another video by Maths with Sarah. So today we're going to be tackling this question. So it's a quadratic graph question. We've been given the graph of the quadratic curve, told where it intersects the axis, and then we've been asked to work out the equation of the curve. So I asked a few people what topic they thought was most difficult on the GCSE Maths syllabus, and this was the one that kept coming up. So it is a really tough question, I'll be honest, I do agree with them. So this one is from a non-calculator paper, and it is one of the last questions on the paper. So it's question 25 out of 26 or 27. So it's really near the back and definitely kind of talking about like A star grade 9 type question. It is a challenge, but whilst saying that, this question is worth 5 marks. And there are a number of points in this where I think that pretty much everybody can get at least a couple of marks from this question. So don't be put off by the fact that don't see it and think, I can't do that. No way, it's too close to the back. I definitely think most people can get at least a couple of marks from this question. Okay, so as with all of these questions, I encourage you to pause the video now. Have a think about how you would tackle this question and maybe go ahead and do the whole question. And come back once you've had a chance to have a think about it, and I will go through the answer. Okay, so let's have a look at this question together now. So we've been given some information. We've got a quadratic curve, and we can see that it's kind of maybe upside down from what you would normally expect. So when we draw a quadratic curve, we would normally draw it this way up with the axis along here. So this suggests, so before we've even started the question, before we've even read the question, we should be thinking along the lines of this. If this is what a normal curve looks like, and the fact that it's upside down suggests that we've probably got a minus x in there, maybe minus x squared in there. So hopefully when we get to the answer, we'll get a minus x squared. So you can kind of at least have sort of like a little mental check that you've at least got some, you possibly got the right answer right. We can also see that it intersects the y-axis at 18. So this is a point where x equals 0, y equals 18, and that will help us a lot further down the line. And then we've been given 2 other points. We've been shown that it crosses the x-axis at +3 and -3. So that's the point where y equals 0. Okay, so if we now solving this and working out what the equation is very similar to how we would do it for a linear graph. So whereas with a linear graph we would use y equals mx plus c, we would then put in, you normally use 2 different points, and you can use those 2 points to work out what m and what c equal. With quadratics, it's a little bit different. Rather than using y equals mx plus c, we're going to use y equals ax squared plus bx plus c. And this is why we need 3 points, because we've been given 3 different unknowns. And so we're essentially going to have to use something very similar to simultaneous equations to work out what these 3 values are. So the method that I'm going to show you to do this, it doesn't matter what your 3 points are. So if you were given 3 points and none of them are on the axis, that wouldn't matter. You'd still be able to use exactly the same method to work it out. So if we've got 3 different points, so we know that at the first point that it's been given, we know that when x equals -3, y equals 0, and we'll call this number 1. We then got another point where we know that if x equals 3, y equals 0, and we'll call this kind of knowns 2. And then the last point is where x equals 0, so this is the point where it crosses the y-axis. We've got y equals 18, and we'll call this kind of number 3. So if we substitute, we'll start with number 3. Actually, I probably should have done this the other way around, because then it would have made a little bit more sense, but it's a bit late now. So if we start with number 3 and we pop these values into this equation, we can start with, we know that if we substitute in y equals 18, we can then substitute in x equals 0. So if we do x squared, 0 squared would be 0, times by a just gives you 0. And the same for b, because x equals 0, this whole term is going to equal 0. And then we're going to have plus c. So as you can hopefully tell from this equation, we're going to end up with c equals 18. And this is the point where I think that most people will be capable of getting to this point, and you do get at least 1, if not 2 marks for this point, for getting this working out what c equals. So it is really important that even if you don't feel like you can tackle the whole question, even just jotting a few notes down, having a think about where you would go with this, and if you can get to this point, that's really good. That's another couple of marks that you wouldn't have got otherwise. So well done for that. So if we now look at the other two values, if we substitute in for 1, we know that y equals 0, and then we've got a times minus 3 squared. So minus times a minus and a plus. So then we're going to end up with 9a, or 3 times 3 minus 3 times minus 3 is 9, and then we've got plus bx, so that's going to, we know that x is minus 3, so that's going to give us minus 3b plus c. And then if we do the same for the second equation, again, we've got y equals 0. Again, we're going to have 9a, because 3 squared, or 3 times 3 is 9, so we're going to have 9a again. This time the difference will be that because we've substituted in plus 3 for x, then we're going to end up with plus 3b, and again we're going to have plus c. Now, because we know we're likely to be using some simultaneous equations, these two quite handily equal each other at the moment, so we can set these two, or they both equal the same thing, sorry, so we can set these two equal to each other. So we can have 9a minus 3b plus c is equal to 9a plus 3b plus c. Now you notice that we've got a plus c on both sides, so if we subtract c from both sides, we're just going to end up with nothing, no c's at all. If we do the same, we can end up with, we can take away 9a from both sides, and if we do that, then we're going to be left with minus 3b equals plus 3b. So now if we add 3b to both sides, let's add 3b to this side, we're going to end up with 0 equals 6b. So hopefully you see where we're going with this. We're going to end up with b equals 0. So I think the hardest point with finding this is realising that you've got to set these two equal to each other. And I think it really helps thinking that you are essentially very similar to when using y equals mx plus c and you're doing it for linear graphs. It is essentially just one big simultaneous equation to work out what, in that case, m and c are, or in this case, a, b, and c are. So now if we go back to this equation here, we know that y equals 18. So we can substitute in y equals 18. We'll then know that, sorry, I've done the wrong equation. I was getting confused. I was looking at my notes. It didn't make any sense. So if we go back to this equation, this will make more sense. So we've got 0 equals 9a plus 3b. Obviously, we know that b equals 0, so that's nothing. We can kind of ignore that, and then we know now. So I'm just going to write it anyway. So we'll write 3 times 0, and then we're going to add c. And again, we know that c equals 18 at this point. So now you're going to notice that we've ended up with 9a plus 18 equals 0. So from that, you're going to end up with minus 18 equals 9a. And then hopefully you realise from this that we can get a equals minus 2. So kind of an important point from this is that at the beginning, because we could see that the graph was upside down, or the opposite way around to the way that we would normally see them, we were able to deduce that we were probably going to end up with a minus x squared in this. And obviously this we now have. So that kind of is a little sort of way of checking that what you've got as an answer seems pretty reasonable. So if we substitute all these back into this equation here, we're going to end up with y equals minus 2x squared. We've got no b, so we've got no, because this would always be 0 times x, so we've got nothing there, plus 18. Okay, and that will be our final answer. So that was a really tricky question, and there were a lot of steps in that. I really don't think this is by far, I really do think this is one of the most challenging questions I've actually seen on a GCSE Maths paper, especially for a non-calculator one. So yeah, hopefully that all made sense. If you're struggling with anything, just drop me a message in the comments. And lastly, please like and subscribe to the channel so that I can just keep putting more videos on there. Thank you for watching.